The abdominal cavity houses an array of organs that are vital for digestion, absorption, excretion, metabolism, and immune function. For students in radiography and in the broader medical field, a detailed understanding of these organs are essential. So, what is the abdominal cavity? The abdominal cavity is the largest hollow space in the human body, bounded superiorly by the diaphragm and inferiorly by the pelvic brim. It is enclosed by the abdominal walls and peritoneum and contains major organs grouped into several systems: the digestive system, the urinary system, and the components of the endocrine and lymphatic system. So radiographically, the abdomen is often assessed through modalities such as X-rays, ultrasound, CT, which is computed tomography, and MRI, which is magnetic resonance imaging. So let's start with the digestive organs. The first digestive organ is the stomach. The stomach is a muscular J-shaped organ located at the left upper quadrant. It plays a crucial role in mechanical and chemical digestion. Radiographically, the stomach is often visualized in barium swallow studies or using CT scans. Common conditions such as gastric ulcers, tumors, and gastric outlet obstruction can be detected using these modalities or examination. The second organ is the small intestine. The small intestine consists of the duodenum, the jejunum, and the ileum. It is responsible for most nutrient absorption. In imaging, barium studies or CT enterography helps to assess disorders such as Crohn's disease, obstruction, and tumors. So, you can say Crohn's disease, obstruction, and detection of tumors are actually indication for barium studies in radiography. The third organ is the large intestine, also called the colon. The large intestine frames the abdomen and includes the cecum, the ascending column, transverse column, descending column, and sigmoid column, and also the rectum. Its main role include water absorption and feces formation. Radiologically, the column is often evaluated through the abdominal X-rays, CT scans, and barium enemas. Important pathologies include the colorectal cancer, diverticulosis, and inflammatory bowel disease can be detected using barium edemas. So you can actually say colorectal cancer, inflammatory bowel disease, and diverticulosis are indication for barium edemas. Let's move over to the second group of organ, which is the digestive organs. And let's start with the liver. The liver is the largest internal organ located in the right upper quadrant. It performs vital functions including detoxification, bile production, and metabolism of nutrients and drugs. In radiography, the liver is well evaluated through ultrasound, CT, or MRI examination. Common liver conditions include hepatitis, fatty liver disease, and liver tumors, among others. The liver's vascular structures, such as the portal vein and the hepatic veins, are also crucial in Doppler studies. So when you are doing the Doppler study, either using ultrasound, you can actually detect which blood vessel is carrying blood away from the heart or to the heart, and this will help you detect which one is the portal vein or the hepatic veins. The second organ on the accessory digestive organs are the gallbladder. The gallbladder is located under the liver. The gallbladder stores and concentrates bile. Commonly assessed via ultrasound, especially for detecting gallstones, which is also called cholecystitis and also cholecystitis. Now the third organ is the pancreas. The pancreas lies posteriorly to the stomach and has both exocrine and endocrine functions. It releases digestive enzymes and hormones like insulin. On imaging, the pancreas is typically evaluated via CT and MRI for conditions such as pancreatitis, pancreatic cancer, and cysts. It is often difficult to assess via ultrasound due to overly bowel gas. But that does not mean the pancreas is not assessed using ultrasound. By the way, ultrasound is actually the cheapest examination, and the pancreas can sometimes be assessed using ultrasound. Now let's move over to the urinary system organs. And the first on the list here is the kidneys. The kidneys are retroperitoneal organs located on the either side of the vertebral column. They filter blood, produce urine, and regulate electrolyte balance. Radiographically, the kidneys are well visualized using ultrasound, CT, and IV urography. Pathologies such as kidney stone, hydronephrosis, tumors, and polycystic kidney disease are often detected using ultrasound, CT, or IV urography. The second organ in this group is the ureters and bladder. The ureters actually transport urine from the kidney to the urinary bladder, which stores it until excretion. The bladder is situated in the pelvic cavity, but often assessed in abdominal imaging. Another group of organ is the endocrine and the lymphatic structures. The adrenal glands are located on top of the kidneys and they secrete hormones like cortisol, aldosterone, and adrenaline. CT and MRI are used to assess the adrenal adenomas and hyperplasia. Now, the second organ on this group are the lymph nodes and vessels. Abdominal lymph are part of the immune system and they drain fluid from various abdominal organs. They are visualized during imaging of conditions such as lymphoma, infections, and metastasis. So, you can say an enlarged lymph nodes on CT can indicate systemic disease. Now let's talk about peritoneum and retroperitoneum. The retroperitoneum is a serous membrane that lines the abdominal cavity and covers the organs. The peritoneal cavity may contain ascitic fluid in conditions such as liver cirrhosis. Now, imaging may reveal free air in cases of bowel perforation, which is a radiologic emergency. For the retroperitoneum, on the other hand, it houses organs such as the kidney, the adrenal glands, and the pancreas, and also the aorta. Masses or hemorrhage here can be subtly detected using CT or MRI, and sometimes ultrasound. So in conclusion, a solid grasp of the abdominal organ and anatomy and also pathology is essential for radiography students and other medical students alike. These organs, though distinct in function, are intricately connected in structure and pathology.